In this problem, we're told that a 50 ohm resistor is connected in series with a 30 ohm resistor. So we can draw it something like this. Here's a 50 ohm resistor and a 30 ohm resistor. The power dissipated in the 50 ohm resistor is 32 watts. So right here, we're told that the power is 32 watts. That's in that resistor alone. And we want to know what is the total voltage across both resistors. Well, let's think about this resistor. We know the power is 32 watts, and we know the resistance is 50 ohms. And we have this equation that says P equals I squared R. And we know P and we know R, so we can find I. I squared will be P over R, and let's do that calculation. That's 50 ohms over 32 watts. And that comes out to 0.64, and that's going to end up being amps squared because we have I squared here. To find I, we need to take the square root of that. So I'm going to continue this up here. I is the square root of 0.64, which is 0.8. So there's 0.8 amps of current flowing through that resistor. Now these are in series, and in series the current is the same. So there's 0.8 amps flowing through the other resistor. That's the total current. So we can just take Ohm's law, and we can use the total current and the total resistance. And the total resistance we can do in our head. That's going to be 50 plus 30, or 80 ohms. And then the current there is going to be 0.8 amps. So V is just going to be 0.8 amps times 80 ohms. And that's going to equal 64 volts. In this problem, we're told that a 15 ohm resistor, a 20 ohm resistor, and a 30 ohm resistor are connected in parallel across a 44 volt battery. Find the voltage and the current in each resistor. Okay, let's just give these names. R1 will be the 15 ohm resistor. R2 will be the 20 ohm resistor. And R3 will be the 30 ohm resistor. And the resistors are in parallel, so the voltage in each one of these is 44 volts. So V1 is 44 volts, V2 is 44 volts, and V3 is 44 volts. And from there, it's trivial to calculate the current in each resistor. I1 will be V1 over R1. So that's 44 volts over 15 ohms. That comes out to 2.93 amps. And then we do a similar calculation for the current in resistor 2 and resistor 3. I2 will be V2 over R2, 44 volts over 20 ohms. That comes out to 2.2 amps. And I3 will be V3 over R3, and that's 44 volts over 30 ohms, and that comes out to 1.47 amps. And in this problem, we're told that in a particular passenger aircraft, 80 light bulbs are connected in a parallel circuit. So these might be the lights along the various seats in the aircraft. And they're on a parallel circuit, so if you turn one off, the others can remain on. The power source, we're told, is 24 volts. Each bulb uses 12 watts of power. Find the current in each bulb, the total current provided by the power source, and the total power provided by the power source. And these are the kind of things we would need to know if we were an engineer designing this aircraft or assembling this aircraft. These are the kind of things that would be important. We would need to know the power provided, so we would know how big a power source to use on the aircraft, how much power might be available for these systems as opposed to other systems. All sorts of things are going to need to be calculated in the design of an aircraft, and this is one of them. So let's solve this. First, we're going to find the current in each bulb. Well, we know the voltage is 24 volts. That's given in the problem. And these are in parallel, so the voltage in all of these bulbs is 24 volts. And we're told that each bulb uses 12 watts of power. So I'm going to write that. The power is 12 watts. And I have this equation, P equals IV. So I can find I. I will just be P over V. That's 12 watts over 24 volts. It's 0.5. 0.5 amps is the current. So we're told find the current in each bulb. We just found it. Each bulb has a voltage of 24 volts and a power of 12 watts. So the current in each bulb is 0.5 amps. And we're also told to find the total current provided by the power source. Well, there's 80 bulbs and they're in parallel, and in parallel the currents all add up. So each of 80 bulbs is going to have 0.5 amps of current. So the total current will just be 80 times this amount. I'll just make a note of that. The total current will be 80 times 0.5 amps. And you can do that in your head. That comes out to 40 amps. And we're told to find the total power. Well, each bulb uses 12 watts, so the total power, my last step, is just going to be that times 80. 12 watts times 80, and that comes out to 960 watts.